Hello and welcome back to Data Analysis series. Today we are going to explore univariate analysis, one of the cornerstone of data science. If you are just starting out, you are in the right place. This is where you begin your journey of understanding data one variable at a time. So let's start with the basic. Univariate analysis is all about analyzing data by focusing on one variable at a time. The term univariate itself tells you we are dealing with a single variable. This might sound simple, but don't let that fools you. Univariate analysis is a powerful tool that helps us to uncover the fundamental characteristic of our data. Why it is important? Because understanding individual variable is the foundation of any data analysis process. It is just like getting to know each member of team before figuring out how they will work together. When we thoroughly understand each variable, we can make better decisions about what to do next, whether it is cleaning the data, selecting feature, or even deciding which model to use. So now let's dive into why univariate analysis is so important. Here are four key reasons: data understanding, identifying patterns, data quality assessment, and the foundation of multivariate analysis. First, data understanding. Before you can analyze relationship between variable, you need to understand each one individually. For example, if you are analyzing customers data, you need to know the basic statistics of each variable like average age or most common product purchased. This basic understanding helps you know what you are dealing with and sets the stage for more complex analysis. Second, identifying the patterns. By looking at one variable at a time, you can spot pattern, trends, and outliner that might not be visible when you look at the entire data set. For example, you might notice that most of our sales occur during the holiday season, or that a particular age group prefer a specific product. Data quality assessment. Univariate analysis is also crucial for checking the quality of your data. By examining the distribution of a value, you can identify the error, inconsistency, or missing data point. For example, if you are analyzing ages and finds that some entries are negative, you know there are problem that needs to be fixed. Foundation of multivariate analysis. Finally, univariate analysis serves a foundation for more complex analysis. Before you start looking at how variables interact with each other, you need to understand each variable on its own. It is like laying the bricks before building a house. Univariate analysis can be divided into three main types: descriptive analysis, inferential analysis, and exploratory analysis. First, descriptive analysis. This type is focused on summarizing the main feature of a single variable. It involves calculating measures like mean, median, mode, range, and standard deviation. These measures helps us to understand where data is centered, how spread out it is, and what typical value looks like. Inferential analysis. This type of analysis allows us to make prediction or inference about a large population based on a sample of data. It is about going beyond the data at hand to make broader conclusion. For instance, if you are analyzing the spending habits of sample customer, you can make prediction about spending habits of all your customer. Inferential analysis used statistical methods like hypothesis testing, confidence interval to make these predictions. Exploratory analysis. In exploratory analysis, the goal is to uncover patterns that insight within a single variable. This often involves using visualization tools like histogram, box plot, or frequency distribution. This visuals helps you to see the shape of data, detect any unusual observations, and understand the general distribution. So let's talk about measure of central tendency. These are statistical measure that tells you about the center of data. The typically or most common values are mean, median, or mode. So first, mean. As I mentioned earlier, the mean is simply average value of your data. It is calculated by summing all the value and dividing by number of observation. The mean is useful when you want a general idea of where the most of data point lies. However, it can be skewed by outliers, extremely high or low values that don't represent the majority of your data. Median. Median is a middle value when your data is ordered from smallest to largest, or vice versa. If you have an odd number of observation, the median is exact middle value. If you have even number, it is average of two middle values. The median is particularly useful when your data has outliers, as it gives you central value without being affected by those extremes. And third is mode. Mode is the value appear more frequently in your datasheet. It is simple but effective measure, especially your categorical data. For example, if you are analyzing the favorite color of a group of people, the mode would be color that most people prefer. While measure of central tendency tells you about the center of data, measure of dispersion tells you about the spread, the variability of data, range, variance, standard deviation, and interquartile range. So first, range. The range is difference between the highest and lowest value in your datasheet. It gives you a basic idea of how spread out the data is, but it is not very informative on its own because it is only considered the extreme values. Variance. Variance measures how far each value in the dataset is from the mean. It is calculated by taking the average of the square difference between each value and the mean. A high variance indicates the data points are spread out in a wider range, while a low variance means they are clustered close to mean. Standard deviation. Standard deviation is the square root of a variance. It is more intuitive to understand because it is the same unit as the data itself. A smaller standard deviation means the data points are closer to mean, while a larger standard deviation means they are more spread out. The interquartile range. The IQR measure the spread of a middle 50% of your data. It is calculated by separating the first quartile 25 percentile from the third quartile 75 percentile. The IQR is particularly useful for identifying outliner and understanding the spread of a central portion of your data. Visualizing data is one of the best way to understand it. Here are some common visualization tool used in univariate analysis. First is histogram, second is bar chart, third is box plot, and fourth is frequency distribution. Histogram. Histogram is a graphical representation of the distribution of continuous variable. It divides the data into bins and shows how many observation falls into each bin. This helps you to see the shape of the data, whether it is skewed, normal, or has a multiple peaks. Bar chart. Bar chart are similar to histogram but are used for categorical data. Each bar represents a category, and the height of bar shows frequency or portion of observation in the category. Bar charts are great for comparing the size of different categories. Third is box plot. Box plot provides a summary of data sets using 5 key numbers: the minimum, first quartile, median, third quartile, and maximum. It also highlights outliers, those data points that falls from far outside them the expected range. Box plot are very good for comparing distribution between different group or variable. A frequency distribution is a table that shows the number of observation for each value or category in your data set. It provides a clear and detailed view of how the data is distributed, which is especially useful for large data sets. While univariate analysis is incredibly useful, it comes with certain assumptions and limitations that you should be aware of. Univariate analysis assumes that the observation and independence the data is Univariate analysis assumes that observations are independent of each other. This means that the value of one observation doesn't affect the value of another. However, this assumption doesn't always hold true, especially in the time series data with inherent independency. For example, in a stock market data, today's price might depend on yesterday's price. Limited insights. Since univariate analysis focus on individual variable, it provides insight with each into each variable characteristic, so that we have very limited insights. In summary, univariate analysis is your first step into world of data analysis. By focusing on one variable at a time, you gain a deep understanding of your data, uncover pattern, access its quality. This foundation is crucial for more advanced analysis like multivariate analysis, where you will look relationship between multiple variables. We will see in further videos. Remember, the key to become proficient in data analysis is practice. So take the time to apply this concept in your own data sheet. You can download it from Kaggle, or many websites are there. Explore different visualization and experiment with the various measures we discussed today. Thank you so much for joining me on this journey through univariate analysis. I hope this video has given you a solid understanding of basic and inspired you to dive deeper into data science. If you enjoyed this video, please give it a thumbs up, subscribe to this channel for more content, and don't forget to hit the bell icon so you never miss an update. If you have any question or comments, feel free to drop them below. I would love to hear that. Until next time, keep exploring data. Happy analysis. Thank you so much.